Hi, welcome to identifying trig at any angle given quadrant information. So this series of questions is about trig functions that have a specific set of given information. So for this first question, which you might have noticed there are 8 for, we'll talk about 2 of them because the information will appear a little bit differently from 1 to 5, which is what we're going to do together. So for number 1, we're asked to determine the value of the given trig function. So we want to know cosecant of theta with the initial side and the terminal side of this angle. So we want to know the side lengths of the triangle that this creates. So the side lengths given are my x as 2 radical 5, my y as 4, and then my hypotenuse is going to be found using the Pythagorean theorem. So we're going to have to churn that out real quick to figure out our last side. And after that, we'll just use what our trig ratio means, which is hypotenuse over opposite, to determine what it equals. So c squared is going to be equal to, I'm going to go ahead and write it as square root of 20, because that's what 2 radical 5 is, squared, plus 4 squared. So c squared is going to be equal to 20 plus 16, and that means c squared is equal to 36. And we are never choosing the negative answer here, so c is going to be equal to 6. And this might be where we could have gotten into a bad habit and forgot about the negative 6 solution, but in this case we do want to leave that out of our answer. So our third side, the hypotenuse, is 6. For cosecant, like I was saying, that's hypotenuse over opposite, because that's the reciprocal of sine. We are going to state our answer as 6 divided by my opposite. So my opposite is going to be 4, which is 3/2. Great. So remember, we want to use the initial and terminal side to create a triangle. This is the only way to create a triangle from that given angle. I know it might be a little confusing with the angle being drawn like that, but this is the only way we can form a triangle from that given information. Now, 5, 6, 7, and 8 are similar because they state the same information, except we have to draw the picture now. So I'm going to do my best to draw an axis here. And then I just need to put this in the correct quadrant, and then I'll be able to form a triangle out of that information. So negative 6 is back this way, and then up radical 13. So radical 13 is the vertical direction in the positive y direction. So we're in our second quadrant. Now I just need to figure out what my hypotenuse is. So c squared is equal to radical 13 squared plus negative 6 squared. So I know that we see a negative side for this triangle, but that's only because it's in the second quadrant. We're never going to receive a negative hypotenuse, even though we're in that second quadrant, not even if we're in the third or fourth quadrant. So our answer here is going to be 13, the square root of whatever 13 plus 6, no, sorry, 36 is, so c is equal to radical 49. Great. So with these questions, I need to know what tangent of that triangle is that we just found. So tangent is going to be, oh man, I'm a big goofball. So let this serve as a lesson. I was just going crazy on this question. I didn't need to do that, did I? Maybe you noticed earlier than I did. But tangent is opposite over adjacent, which we have. We have these those values. So it's going to be tangent of theta is equal to radical 13 over negative 6. Goofball. So it does help to look at what you are, where you're placing your coordinate and what your trig ratio is calling for, tangent. All right, so number 9, we'll do number 9 and then we'll do 13 and we'll be finished here. So number 9 is we just want to find all 6 trig values that are not given. So, or in this case, it's 5 trig values, and we're given cosecant theta. So this is another drawing problem where we're drawing the cosecant of theta and where that is. First, we have to remember that cosecant of theta, like I stated before, is hypotenuse over opposite. So we can place our hypotenuse as radical 5 and our opposite as 2. Or, wait, we need to be careful. Our hypotenuse can't be negative. So, I'm not going to spell that all out. I'm just going to put H. Our hypotenuse has to be positive radical 5, where our opposite needs to be negative 2. So remember, opposite is in reference to a y direction, so we know we're placing it in one of these 2 quadrants. We're placing it in 3 or 4. If you remember with the unit circle, sine, which is how we get an opposite ratio given an angle, is measured in the y direction. So we are choosing negative y values. That's this negative 2 right there. That's how I know I'm looking at negative values. We're also given another condition, and that's cosine of theta is less than 0. So cosine is less than 0 when x, our horizontal direction, is negative. So this means x is negative when cosine is less than 0. So x is only negative in this quadrant. We are drawing our triangle in that 3rd quadrant, not the 4th. So you'll have to play this game with 9, 10, 11, and 12, where you're drawing this triangle in the right quadrant given a couple conditions. So this triangle that has a negative 2 opposite side and a hypotenuse of radical 5, beautiful triangle, is going to be drawn right here. So the remainder of the work that I've got to do revolves around using the Pythagorean theorem and working out the remaining trig ratios. So I'll work out the Pythagorean theorem right now, and then you can figure out, well, the rest of the trig ratios I don't get to. So my last side I want to find is going to be adjacent, so a squared. So that would be 1. Yeah, 1. There we go. So if I'm asked for, well, number 1, if I'm asked for sine of theta, that's probably the easiest one to get. That's just negative 2 over radical 5. If I'm asked for cosine, that's when I want to use my new side that I found, which is my adjacent over hypotenuse. And in case you're wondering, yes, it is proper for you to simplify these and to rationalize these, I should say. And then I'll get tangent here real quick. So tangent of theta is going to be my opposite over adjacent, so -2. All right. Perhaps the toughest ones because the conditions involved a sneaky negative sign on this one that you need to watch out for. Now, 13 is also a bit tricky. 13 and 14 are. We're given a point that goes through, that is part of the line that goes through the origin. So this point, -3, 3 radical 3, is going to be going through a line, going through the origin, and well, a line goes through that point and the origin. And we want to determine the equation of that line, and we want to evaluate the indicated trig functions. So the line that we're dealing with is, well, I'm just going to do point slope to figure that out. So y minus 3 radical 3, hopefully you remember that, equals m x plus 3. And my slope is actually going to be my y value divided by my my x value. And in case you didn't realize that, if we draw this triangle here, just show these ratios on the drawing, oops, then you'll see that that ratio is the tangent ratio for this triangle that I just drew. So this is tangent of theta. Or in other words, it's just negative radical 3. So my slope is going to be given by tangent of theta. So if you want to figure that out on something like this, it's just tangent theta. And I'll just change this real quick. It's negative radical 3. And then I can write my equation of the line. And then you can probably guess how you get cosine of theta. That's going to be how we've done it from the previous question. So y is equal to negative radical 3 x minus 3 radical 3 plus 3 radical 3. Yeah, and that's how it should look with this line, because it doesn't have any y-intercept. So this is the equation of our line. And if we're evaluating the indicated trig function with that given information, then I just need to find the hypotenuse, which again can be found with the Pythagorean theorem, and then we'll be done. So I guess I'll go ahead and do that too. Yeah. So I have, was that radical 27? Radical 27 plus 9 squared equals hypotenuse squared. So we can get our cosine function. Square root of 27 plus 81. What is that? There we go. So h is equal to radical 108, which there's a 36 in 108, and we can take out the 6 to simplify our h. So, sorry, that's not the final answer. Our final answer is going to be adjacent, so negative radical 3 over 6 radical 3, which is negative radical 3 over 2. All right. So thank you for watching. You should practice the rest of these for homework, and I'll see you guys in the next one. See ya.